everyone, today I'll be presenting to you about polyvinyl chloride, also known as PVC, or as we call it, the customizable plastic. It can be found in materials that we come across in life, for example, water pipes, window frames, and car tires, for example. And it was invented by Waldo Semen. And the invention was more of an accidental one because it wasn't initially targeted towards solving a specific problem, but it was invented while Semen was trying to figure out how to make rubber stick to metal. And his approach to this initial goal of having to make rubber stick to metal was trying to heat PVC up and remove the chlorine, but it just ended up the PVC just ended up being soft and flexible, and it would get molded. It can be molded into different shapes. So then that was how Semen figured out, oh, there's more to investigate in. And that's how he invented what we now call the plasticized PVC. And the initial process, as we kind of described, was to heat it up and then cool it down, and then the PVC kind of becomes this flexible material. But later on, Semen discovered that having the PVC in powder form first and adding something called plasticizer would also yield the same outcome. So that is the improved process that he opted for later on because it's way more efficient. And the challenge that he faced was not, it wasn't as much on the technical side, but more of to get people to be accepting of the idea, because PVC at the time was a material that people saw as really useless because they couldn't really figure out what to use it for. So then, because people are so used to this idea that there's not much purpose, there's not much stuff that PVC can be used for doing. So it was really hard convincing people of the idea that, oh, actually PVC can be so useful. And that was kind of the same with the investor, as when Semen first approached the investor was kind of indifferent about it until Semen figured out that putting PVC on fabric would make it waterproof. So then that kind of appealed to the investor, and that was how kind of all of this started and how PVC got on the market and become so popular. So the current production process, it still uses the same powder method that Semen derived, but more specifically, it is from seawater, salt, and oil. They get combined into a powder and then gets heated up into a paste and then cools down and get molded into different shapes. And during this process, a lot of different additives are added to give the PVC specific properties. And this is kind of a really detailed diagram of how the production process works, but in reference to that, I created a more simplified one that basically is the same as this, but it highlights the key steps. So as we can see from salt and oil, there's chlorine and ethylene are derived, and they combined, forming vinyl chloride monomer. So basically what a monomer is it's the building blocks of a polymer. And so PVC is a polymer, and a polymer is basically built out of many monomers. So yeah, so there's the vinyl chloride monomer, and then it goes through a process called polymerization, which is basically the monomers just like coming together, forming this polymer, which is the polyvinyl chloride resin. That is the powder we've been talking about. And then from there, the powder, it gets heated up, and then the additives get added into it. And then, well, while it's heated up, it turns into like a thick paste, and then the additives get added to it. And this process is called gelation. So then after gelation, it gets like cooled down, and like it's like molded into different shapes, and then we get the desired PVC compound. And this is kind of like an even more detailed process flow diagram of how the monomer goes through all these steps to become the PVC. But this is just for reference. And this is basically the structure of, well, on the left, it's the structure of the monomer. And then you can see after the polymerization, it's kind of like, it's just a lot of these monomers together. And then like on the right, you can see the structure of the polymer. So it's like basically the same, like it's basically the same, but the polymer is just a lot of monomers bonded together. And the advantages of PVC is that it's really versatile because different additives can be added to achieve different properties that people desire. So it can be used for many different things. And also the production process, it's low cost and low energy. And the material is so resistant to like many different things. And given that if you add like additives that make it more resistant to even like more things, it becomes even stronger and lasts even longer. And so yeah, and its byproducts can also be used for manufacturing other materials. So that is really helpful. Some limitations include that PVC is, well, compared to other polymers, PVC is more like unstable and it degrades at a lower temperature. And it's just a fun fact that the degradation reaction is a first order reaction. And yeah, and also PVC deteriorates over time, and it can even crack when like exposed to too much UV, because like PVC gets weakened by it. And so it cannot really be used under extreme conditions. But some helpful solutions include like adding stabilizers and like specific plasticizers that would not like cause plasticizer migration. What plasticizer migration is basically like plasticizer migrating out of the material. So when we use specific plasticizers, that would be less likely to happen. And if we coat the PVC, then the plasticizer, basically it can't escape. So yeah. And some developments include developments are more focused on like the variety of additives that is like still growing, because it's like the more additives you add and the more different types of additives you add, you achieve different properties. So that's kind of like how it's developing. And also like different colors can be achieved. So some additional thoughts would be that like, are there more applications of PVC on fabric that can be like derived, and like can PVC be used along other substances? So this is something to look forward to in the future. And these are some references. And yeah, that is the end of our presentation. Thank you for listening, and I hope you learned something about PVC.